MT-FIMMPROP is a brand new design environment from Photon Design and is an optional module to their flagship FIMWave software. MT stands for multiple topology, and it allows for the simulation of the entire PIC, the entire photonic integrated circuit, using EME methods, eigenmode expansion methods. And I'll just demonstrate the use of the software in a very simple demo in this short video. So what we have in front of me is an empty design environment. It's just a computational area of 12 microns by 12 microns. And we'll just do a simple S-bend. And the first thing we're going to do to set this up is choose what type of path we want to draw in the window. And we're going to choose the expression path. And I'm just going to draw it out like that. And then I'm just going to click on it to actually edit the specific details here. We'll put it at the side, expanding the whole, an offset of 10 in the X direction. X is the vertical direction, and Z is the length of the device, 12. So there's our S-bend axis there, if you will. What we do next is define an actual path which has a physical width to it. So we move over on the toolbar to the path options, and there's a variety of options if we want to create a taper or something like that, but in this case we'll just use a fixed width, and I just click on the path, and there's our fixed width. How did it know what width to select? Well, I've already defined this as a variable. You'll see here on the right hand side, my core width is 0.5 microns. Of course, if I hadn't predetermined that, I can click here and drag it in size if I wish, but I'll keep the variable of 0.5 microns. Next, we want to do is just add an input port and an output port. So I click on the yellow button on the toolbar and just click a port here and a port here. So number 1, number 2. And then finally, before we can do a simulation, is click on what's called the computational region. So that defines the area which will be used to calculate the modes. So I'm going to click on this button here and then click on the path, and it's already defined a computational region. So it's the same, it follows the axis of the waveguide with a certain extension beyond it. That extension here, again, is defined. I've predefined this just for the simple demo using a variable comp region width of 2 microns. Okay. Then just before we do a simulation, I'm going to edit the details of this port and say we want to input the fundamental mode into that port there. And that's all we need to do a simulation. We've already predetermined the refractive index of this blue region in this case, so I didn't have to bother setting that up for this example. So we're good to go. I'm going to click on the FIMMPROP engine button, and this is where we define how many modes we want to calculate in this computational region and a variety of parameters there. So what we're going to do here is use the FDM, finite difference mode solver, calculate 4 modes in each section along the axis, and that's all, should be good to go. So first thing we'll do is click the scattering matrix button. So this has told us coupling from port 1 to port 2. Of course there's only 2 ports, but there's the 2 ports listed there, and mode 1 of port 1 couples to mode 1 of port 2 99.99%. So we have a very efficient S-bend here. Okay. So that's the scattering matrix. If I wanted to plot the field, I click the plot field button and click OK. It takes a few seconds to get the field values and draw them to the screen. But there you can see our S-bend right there. And looking very highly efficient. Once you've done the design of your PIC or S-bend or waveguide, we can export to GDS2 for fabrication. So MT-FIMMPROP is both a groundbreaking way to model photonic integrated circuits using EME methods, but it's also combining the roles of layout and simulation for those of you who need to design photonic integrated circuits.